Hey, pre-algebra, we are at the end of chapter 4. We're looking at section 4.6, and we're going to be dealing with writing equations and translating English sentences into equations. So that's going to be the brunt or the basics of what we're going to talk about, and let's get started with some examples. So the first set of examples requires us to simply change each of these or turn each of these statements into equations. So let's look at this first one. We've got Zach has 6 shirts. This is 4 less than twice the number of shirts N that Xavier has. So here's a couple things we need to do. I would like us to, let me get my pencil in order. I'd like us to observe this very special word, is. Is going to be one of the most important words because this tells me where to put my equal sign. So when I say something is equal to or is less than, I'm saying it is equal to. I'm giving that really means equal to, so I want you to hold on to that. So here it says Zach has 6 shirts. So 6 is in our equation, and it says this is, what are we referring to? We're referring to Zach's 6 shirts. So this equals 4 less than twice the number of shirts N that Xavier has. Now Xavier's shirts, the number of shirts that Xavier has is being referred to as N. So 4 less than 2 times Xavier's shirts. 4 less than 2 times. Well, we're comparing it to 2 times Xavier's shirts, which we write as 2N, but 4 less is a little bit tricky. Some students like to write 4 minus 2N, but think, what does 4 less mean? It means to take away from a particular thing. And we're talking about 2 times Xavier's shirts. So we've got 6 is equal to 2N minus 4. Let's take a look at this next example. It says 8 more than the quotient of a number and y. I'm sorry, a number y and negative 3 is negative 24. What I'm thinking is I want to move some of this stuff out of the way. So I'm going to do that really quickly, so we can see a little bit better what we're talking about. So here's this first problem. I'm going to put the answer there and come over here. So 8 more, we're looking at this guy over here. We're talking about 8 more than the quotient of a number y and negative 3 is negative 24. Well, the is negative 24 tells me equals negative 24 is going to be a part of our problem. Now, 8 more than I hope you recognize as an addition word. We know that we're going to be adding when we hear more than. Quotient means division, so we're dividing 2 things. Quotient honestly means the answer you get when you're dividing some numbers. So 8 more than the quotient of. So 8 more than means that I'm adding 8 to something. What am I adding 8 to? I'm adding 8 to the quotient of something. So I'm going to divide something. What am I going to divide? I'm dividing y and negative 3. So y is being divided by negative 3. How did I know it was y being divided by negative 3 and not negative 3 divided by y? I take it in order, just as it comes. So when it says the quotient of something and something, the first thing is going to be the dividend, or the number at the top, and the last number is going to be the divisor, or the number at the bottom. So this is the equation I get. Y divided by negative 3 plus 8 is equal to negative 24. Let's do this final example. Jeremy has 13 baseball cards, which is 7 more than 3 times the number M that Michael's has. So we've got 13 baseball cards, which is, so 13 is equal to something. It is equal to 7 more than 3 times the amount that Michael has. So what I like to do sometimes is just compare the 2 things. I'm comparing Jeremy's 13 to 3 times the amount that Michael has. But now I've got to figure out what to do with this 7. How do I make this situation equal? Well, if Jeremy has 13 and that is 7 more than 3 times Michael's, to make it equal, I'm going to have to add 7 to the side with 3 times Michael. I can do this another way. You might have realized that I could have made it equal a different way. Again, let me put the 3M here. Again, we're comparing Jeremy's 13 and 3 times Michael's amount. Instead of adding 7 to Michael's amount, I could have subtracted 7 from Jeremy's amount. Both of these are satisfactory equations for this statement. Let's move down and take a look at another example. Let's see what we have. Example 2. So sometimes when we have these problems, we're not just going to write an equation, we're going to actually write and solve. So in this problem, this is a little bit challenging, but we can handle it. Juan's father was 29 years old when Juan was born. This year, the sum of their ages is 53. Find their ages. So we're going to let X refer to Juan's age. X is Juan's age, right? Because that's one of the things we're looking for. So if X is Juan's age, what would his father's age be? His father's age would have to be X plus 29, because we remember from the problem that when Juan was born, his dad was 29 years old. So X plus 29 is Juan's father's current age. Juan's father's age, all right? So that's what we have. Now we know that this year, the sum means addition, the sum of their ages is 53. So I'm going to do X plus 29. So this is Juan's age plus his dad's age is equal to 53. And this is an equation that I'm going to solve. X plus X is 2X, so I'm simplifying the left side of the equation. And then I'm going to solve it like I do any other equation. Couple steps here. I'm going to subtract 29 from both sides. So with my 2x plus 29 equals 53, when I subtract 29 from both sides, I am left with, on the left side, 2x. But on the right side, I'm left with 24. And so now I've got 2x times 2 times x is equal to 24. I need to divide both sides by 2 to undo that multiplication. So I'm left with, let me get rid of that. I'm left with x is equal to 12. So that's Juan's age. So how old is his dad? His dad is x plus 29 or 12 plus 29. Juan's father is therefore, let me see if I could put it here. I don't think I can fit it, barely, is 41. So Juan's dad is 41 and Juan is 12 years old. All right, let's take a look at another example. So example 3, it's talking about solving a 2-step verbal problem. So we've got this guy, Logan. He's collecting pledges for a charity walkathon. He's going to receive an initial contribution of $68. Bam. Nothing else, $68. Let's say from one person, they're going to give him $68 just for participating. And then when he calculates all the money that he's getting from other people, he realizes that it's going to be $20 per mile that he walks. So the amount of money is going to be dependent on, yes, the $68 initially, but the $20 for each mile that he walks. How many miles will he need to walk in order to raise $348? So what we'll do is we will first define the variable thing, because the thing that's going to change here, or the thing that we don't know about, is how many miles he walks. So let M be the number, I'm going to use that symbol, of miles Logan walks. So if that's the number of miles that he walks, what we're going to do is recognize that he starts off with $68 plus $20 per mile. So that'll be 20 times each mile, right? And we want that to equal to $348. So we need to solve this equation. Whenever I have problems like this, let me scroll down a bit, give myself some more space. And you see we're going to get to the assignment really soon, so I'm going to start working into the assignment section. Whenever I have a problem like this, I like to draw a line straight down the center and to call one side my variable side, or my M term side, as it is in this case. So I want my M terms on this side, and on the opposite side I want my constants, and I'm going to write that in red. Constants. And we remember what constants are, right? Constants are numbers that are just hanging out by themselves. There's no variable attached to them. Constants are exactly what they are. They're just numbers. They're constantly the same thing. When I see 68, it's 68. But when I see 20M, in this problem, M could be something, and another problem, M could be something else. So that varies. So this is a variable term, and this is a constant term. So I need to get all my constants out of here. This is a variable term, so 20M is cool. I need to get rid of this 68. Positive 68, I'm going to add a negative 68, doing the opposite to get, what do we call it, the additive inverse. Big words, you guys remember that? We cancel that out. I've got a 0 over here in terms of my constants, and I'm just left with the 20M. On this side, I'm going to join 348, and I'm going to subtract 68. And when I do that, I think I get something like 280. I believe that's right. And so we're almost finished our work. Now what we need to do is divide both sides by the coefficient of m. So I'm dividing both sides by 20, right? 20 cancels out, and I'm left with m is equal to, well, the 2's cancel out, the 0's cancel out there, pardon me. 2 goes into 28 14 times. M is equal to 14. So Logan was doing some running, or walking, as it were. He walked 14 miles. And that's what we have. If I was doing this regularly, there would be some really cool music. Maybe I can get some cool music for you guys really quick to tell you what the assignment is. Let's see some cool music. Do I have it? Nothing? There we go. All right, people. The assignment is pages 208 to 210. Please do problems 7 through 19. And then 21, 23, 25, 28, 30, 33. Have a good one. I'll see you all tomorrow. Nobody wants to see me dance. Peace out. Bye-bye, guys.